Have you ever just sat and wondered, why does a soccer ball stay still until you kick it? Or why, no matter how long you stare at it, it never just rolls away on its own? It's almost like there's an invisible rule book that everything around us is following, even if we can't see it. Or why your ice cream falls straight to the ground when you drop it instead of floating away. Why do things always seem to fall down, never up? Why don't they just hang in the air or drift off into space? These everyday mysteries might seem simple, but they're actually clues to some of the most important secrets of the universe. Well, that's all thanks to one brilliant guy, Sir Isaac Newton. He was a scientist, mathematician, and all-around genius who lived over 300 years ago, but his ideas are still shaping our world today. Back in the 1600s, Newton basically wrote the rule book for how things move. He didn't just make up these rules, he observed the world, asked questions, and used experiments to figure out what was really going on. His discoveries changed science forever. We know them as Newton's laws of motion, and trust me, they're way cooler than they sound. These laws explain everything from why you need to wear a seatbelt in a car, to how rockets launch into space, to why you can't just float off your chair right now. Let's start with his very first law, the one that kicks it all off. It's called Newton's first law, also called the law of inertia. Here's the deal. If something is just chilling, like your phone on your desk, it's not gonna suddenly slide off or jump up. Unless you poke it. In other words, things like to keep doing what they're already doing. If they're still, they stay still. If they're moving, they keep moving. Objects at rest want to stay at rest. That's inertia, the stubbornness of objects to change what they're doing. It's why your coffee mug doesn't leap off the table, and why you need to actually push your chair to move it. And if something is already moving, like a skateboard rolling down the sidewalk, it keeps moving until something stops it, like your foot or a patch of grass. That's why you need brakes on a bike, or why a soccer ball eventually stops rolling when it hits the goal net, or the grass slows it down. So basically, things don't move or stop moving unless something makes them. This law is everywhere, from the way a car keeps going after you take your foot off the gas, to why you lurch forward when a bus suddenly stops. Now on to the second law, Newton's second law of motion. This one's got a bit of math, but don't worry, it's simple. This law explains how things speed up, slow down, or change direction. It's all about how much force you use and how heavy the thing is. Newton realized the bigger something is, the more force you need to get it moving. Try pushing a heavy box across the floor. It takes a lot more effort than sliding a book. The heavier the object, the harder you have to push. Like pushing an empty shopping cart is easy. Add a couple bags of potatoes and suddenly you need some muscle. The more mass, the more force you need. And if you want it to go faster, you have to push even harder. This is where the famous formula comes in. F equals sine ma. That's force equals mass times acceleration. It's like a recipe for motion. How much you want something to speed up depends on how heavy it is and how hard you push. That means force equals mass times acceleration. So if you double the mass, you need double the force to get the same acceleration. Or, if you want something to go twice as fast, you have to push twice as hard. So, if you want to move something heavy, you either push harder or accept that it's going to move slower. This law is why athletes train to get stronger, and why engineers design powerful engines for big trucks and rockets. And finally, the third law, Newton's third law of motion. This one is all about interactions between objects. It's the law that says for every action there's an equal and opposite reaction. You've probably heard this one before. For every action, there's an equal and opposite reaction. It sounds like a tongue twister, but it's actually super simple once you see it in action. Sounds fancy, but think about when you jump off a small boat. The boat moves backward, right? That's because your jump pushes the boat in the opposite direction. That's Newton's third law in action. Every time you push on something, it pushes back on you just as hard, but in the opposite direction. Your push off the boat, the action, makes the boat push back the other way, the reaction. This is why you move forward when you swim. You push water backward, and the water pushes you forward. It's why rockets blast off. The engines push down on the ground, and the rocket zooms up into the sky. Even walking is an example. Your feet push back on the ground, and the ground pushes you forward. The engines push down and the rocket goes up. It's the ultimate teamwork between forces, and it's happening all around us, all the time. So next time you're riding your bike, tossing a ball, or just watching rainfall, remember you're seeing Newton's laws in action. Every movement, every stop, every jump, and every fall is a little piece of Newton's genius at work. And who knows, maybe your next apple from the tree moment will change the world too. So keep your eyes open, keep asking questions, and you might just unlock the next big secret of motion.